Okay. All right. Okay. So we're starting now. I'm just going to test it here again. Just to make sure it's working. Testing, 1, 2, 3.
Test it.
Yeah, it's working. Okay. Alright, so welcome to this lecture. I'll just send a message to this effect. Something went wrong. It's not being sent. Okay. What's going on? Okay, there we go. So now it's working now. Oops. Okay, got it. Okay, so I just sent a message asking if you could please let me know if you're watching, and also if you have any questions. Okay. Particular questions on the questions that we discussed in homework that I gave you for homework. If you could please ask them, or you could send them by email, and I can try to deal with them during a live lecture. All right. Okay, so if not, then I'd like to discuss the coming chapters. Chapter 4. Okay, let's see here. Chapter 4 is about linear functions. And so, since that should be a review for most of you, all of you, in fact, if you've taken Math 098, 099, or Math 101 before, then you already should have a background in linear functions. Okay, but it's good to review some things. And so I might just review some things from this chapter and then move on, and then we can always go back to this chapter if you need more review on this chapter. But I would urge you to keep on reading according to the schedule that I gave you in the syllabus. Try to read the chapters in advance if you can. That will help, and in that case you can you can see in advance how much work you might need to do in learning that. Or if you've already seen that material before, you can gauge your time accordingly. And spend more time in the chapters that you don't know much about, that you haven't learned yet. Okay, so, and we'll be coming to those shortly, hopefully. Okay, so with linear functions, if you recall, are, well, we have linear equations and linear expressions. So a linear equation, you might recall, is of this form. Y is equal to ax plus b. So a linear function is simply to take the right-hand side and just call that f of x. So linear function is of this form. F of x is equal to ax plus b. And then when we graph the function, we'll be taking y is equal to f of x. So we'll be assigning x as the input and then y will be the output. Then we'll see that what we get in the end here is the same as a linear equation. Okay, so a linear equation will be shown on a graph by a straight line. That's very general. So that's true for all linear equations. Okay, so here you'll have the specific features of the graph. This value is the so-called y-intercept, and that is a value of y when x is equal to 0. So if you plug in x equals 0 into the function, then you get, as output, you get y is equal to b. And then this a, so b can be positive or negative. It can be anywhere along the y-axis. And then independently of b, a will be the slope. So in this case I'll show b and a both positive. So slope is the rise over run of the line. And I'll indicate it by some triangle here where you have the rise being a and the run being 1, and the ratio is in this case a over 1, which is a. So I'm taking as the run 1, and then I can easily write down the unknown slope there as the rise. Okay, practical examples. You can use whatever numbers are convenient here. You can use 2, 3, or 5, 7. So you can use integer numbers so that you don't have to deal with fractions. Okay. So, for example, plus 5x. So you would graph that by measuring off 1, 2, 3 in the y direction along the y-axis. Actually, I'll make this 5 over 7 just so you get. 5 slope would be very large, but let's see, 7. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5. Okay, so the y-intercept will be here. This is of the form, same form as here, where a is 5 over 7 and b is 3. Okay, so the y-intercept is 3, the slope is 5 over 7, and so if you take rise over run, remember what that is, it's the change in y over the change in x. Okay. So if we change, in this case it's 5 over 7. So a convenient, so to speak, we're basically making a right angle triangle to show the line here. Convenient choice of the base of the triangle, like this, okay, that's a right angle triangle, is to choose delta x as 7. So we'll choose it to be 7 here. And then the height will be vertical side will be 5 units up. So this is 7. And then 5 up is up here. And then the hypotenuse of the triangle will be along here, and you just extend that. Now if you have enough graph paper, then you could try to scale your diagram so you could try to check at another point. So if you go down, try to check on the integer point. So you go down 1, 2, 3, 4, 5, and this should be in this direction 1, 2, 3, 4, 5, 6, 7. So it should be roughly down here, and it's not quite there, but I guess my graph is a bit off, but maybe it's a bit too, yeah, it should be like this. Okay. So b is equal to 3. So I erased. Should be 10. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5. Oh, that's right, that should be 8. So if x is 7, y is 3 plus 5 is 8. If x is minus 7, then y is 3 minus 5 is minus 2. Okay, you can also check this by the table, which I just showed. So 0 gives you 3, 7 gives you 5, minus 7 gives you minus 2. So 5 plus 3 is 8. Okay. Now, the value of a, the slope, can have qualitatively two different values, or two different kinds of values, those which are positive and those which are negative. So that changes the qualitative behavior of the graph, in particular whether it's increasing or decreasing. So if a is positive, then the graph is increasing. So remember, that means that as you increase x, as you let x go from left to right, then y will also go upwards. So if x is increasing, y is also increasing. Yeah, upwards is the version of increasing for y, whereas to the left or to the right is the version of increasing for x. Okay, so you can tell immediately from the slope of the graph, which is the x coefficient. In a linear function, you only have the coefficient of x and a constant term. From that coefficient, you can tell right away whether it's an increasing function or decreasing function. If it's positive, then it's increasing. If it's negative, then it's decreasing. Okay, and remember, the slope is independent of I can choose 2 points here to find the slope. That's what I mean by delta y. I mean, I take the coordinates of the first point, which are x1 and y1, and the coordinates of the second point, x2, y2, and then I take delta y is y2 minus y1. That's the height of this right angle triangle, and delta x is x2 minus x1. That's the base of the right angle triangle, and then I divide one by the other. Okay, so for any given linear function with a given slope, then that slope is independent of the choice of the values of the points that I choose to find that slope. Okay. All right, so how many parameters do I need to define a particular linear function? Parameter is some constant, choice of constant in the graph, in the equation, in the formula for the equation, for the function. And you can see right away I have two, these are parameters, A and B. So one parameter determines where the function intersects the y-axis, the y-intercept, the value of y at that point. Of course, the value of x is always 0 there. And the other parameter, A, is the slope. Okay. Okay, so let's try something here. So if you have 1, 2, 3, 1, 2, 3, 4, let's say. Okay, so if you have 2 points, so suppose those 2 points are on the line. Excuse me. Okay, so here's x, here's y. Here's 1, 2, 3, 4. Here's 1, 2, 3, 4, 5. One might ask the question, find, so this is 1, 3. This is 4, 5. So what is the equation of the line? And find another point. Find an easy point. So an easy point would be one, say, which has both x and y equal to integers. So it's not dealing with a fraction. Okay, find the slope as well. So you need to find the slope, or usually you find the slope while you are in the process of finding the equation of the line. So the slope is obtained by taking, we sometimes call the slope m. So you take the change in y over the change in x. Here it's 5. So we'll take x2, y2 to be this point, and x1, y1 to be this point. We could also always take it to be the other way around, in which case the numerator will become negative of this, what I do here, and the denominator will also become negative, but the two negatives will cancel and I'll get the same slope. So it doesn't matter which order you choose them, but you should always be consistent with that order once you do choose it. Okay, so don't put, so you put y2 minus y1 in the numerator and x2 minus x1. So the x2 should line up with the y2 here, and the x1 should line up with the y1 here, x1 with y2, x2 with y1. All right. And yeah, or it could be like this as well. Because I change the sign of both to get from here to here, and that doesn't change the overall ratio. Okay, so here I get 5 minus 3, y2 minus y1. y2 is 5, y1 is 3, x2 is 4, x1 is 1. So we get 2 over 3. The slope is positive 2 over 3. Now I want to find, so far my function that I'm using here. So another way of writing this question is, what is the function describing the line, I should say through the 2 points given, to the 2 points shown. So the function is of this form, ax plus b. I've determined the slope to be 2/3, so I can write that in. And now I just have to find b. Okay, so to find b, I can plug in a known point. So this is equal to y. Y is 3, x is 1. So what does b turn out to be there? I just solve for b once I plug in the x and y coordinates for one point. I could also choose the other point to determine b. Okay. So b is then 3 minus 2/3, which is 9 minus 2 over 3 over 7 over 3. Okay, now to check this with the other point to make sure it's correct. So our function then would be 2x plus 7 over 3. All right, so x equals 1 gives us 3. It gives us 9 over 3, which is 3. 5, x equals 5 gives us 2 times 5 is 10. Sorry, 4. X equals 4 gives us 2 plus 2 times 4 is 8, plus 7 is 15, divided by 3 is 5. So that's equal to y. Okay. So those 2 points check. So this equation is correct. It's determined by just the values of the function at 2 different values of x. Okay, and so plugging my battery and charging here. Okay, and I know the function is increasing because the slope is positive. Okay, so now if I want to find, okay, so here's the line. Speaking, I'll just erase this. These points. So drawing a straight line. Expect to go through this point here. It's not going to go through exactly the integers, except except if I go the same distance across. So I have to go 3 across by x in order to get to another integer, or a multiple of 3 in any direction. So if I start from 1 and y is 3, then if I go up 3 in the x direction, then I go up 2 in the y direction. So if I go to the left by 3, 1, 2, 3, then I should go down by 2 in the y direction. So, because there delta x is equal to minus 2, and then delta y is the slope times minus 3. It's minus 3. The slope times minus 3. Right, because the slope is equal to, m is equal to delta y over delta x. So delta y is equal to the slope m times delta x. I just put the delta x on the other side. Multiply both sides by delta x. So I multiply the slope by the change in x, and then I get the change in y, minus 2. And this point is minus 2, 1. If I check it with an equation, I get minus 2 times 2 is minus 4, plus 7 is 3, over 3 is 1. So that checks out. Okay, so that's my point, extra point, my easy point. The slope is given here, and I've also shown a graph of this straight line. Okay, so I should know various things about linear equations just from what you know about linear functions, just from what you know about linear equations, which you've seen before. Also how to find, so you have different forms of the ways of writing linear equations. We have mx plus b, that's a familiar way to many people. The slope is m there, so that's the slope intercept form. You've shown explicitly the slope and the y intercept. Okay, and then you have also the point slope form. So in this case, you are given the slope and a point x1, y1, and you plug in the slope as a coefficient of x here, but the b value will not be obvious right away. But if you solve for what we did in the previous case, was you solved, given the point, you can solve for the y-intercept, and then write that down. And if you do that, so if you put in y1, so if you have the slope given but not b, all right, then okay, we have somebody. Did they give a question? Okay. I don't see any questions yet. Okay, so if you just put the board in a better position here. I'll put the camera in a better position. Oops. It's too high. Okay, this should be better. Okay. So if we're given m, and this is unknown, but we're also given the point x1, y1, then we can determine what the y-intercept should be by plugging x1, y1 into the form. into the equation. And then we'll get y1 is equal to mx1 plus b, and then we solve for b, and b is y1 minus mx1. So if we put that back into the equation, we get y is equal to mx plus y1 minus mx1, and if we rearrange this, we just get mx minus x1 in brackets plus y1. And that is what we have up here, the point slope form. There's also something called the point-points form. And that's where you write m originally from given 2 points, x1, y1, x2, y2. So given any 2 points, you can write the slope m as y2 minus y1. So you write everything explicitly in terms of the x and y coordinates of both points. So m will be replaced by this form, and the x1 and y1 will be they'll already be written in this form of the coordinates of one of the points. Or you could replace x2 and x1 by x2 and simultaneously y1 by y2, and that will give you actually the same equation, as long as the slope is given by this. So it'll just give you the same equation the way it's written. Okay, so if a function is increasing in some interval, then it's increasing over the entire domain. The domain of a function, domain of this function, a linear function, okay, is what? The domain is, for a and b finite here, all our operations are well defined, so the domain is all real numbers. And what is the range? Okay, so domain looks like this, or going down like this. The range, now the range will depend on the choice of A. So this domain is true for any A or B. The range is R if A is not equal to 0. All right, because if A is not equal to 0, then you have a slope. Then the function is either increasing, strictly increasing, or decreasing. But if A is 0, then what's happening is the function is a constant. F of x is equal to b only. Just take a to be 0 there. So if the function is a constant, then there's only one value in the range. Namely b. So in this case, the function is neither increasing nor decreasing, it's constant. And it's constant over the interval of constancy is, well, it's over the entire domain, which is the reals. Okay. So those are the two cases for the range, whereas the domain is always the same. Now what about, remember there was another case, special case of a equation of a line, and that was when you take x equals a constant. Okay, say it's 2 or something. X equals 2. What's going on here? is this included in our class of linear functions? And the answer is no, because this is not a function. So this graph here fails the vertical line test for a function. In other words, for one value of x, you have infinitely many, not just two or more, you have infinitely many possible values for y. So this does not describe a function at all. Okay. In this case, the slope a would be infinite, or positive or negative infinity, actually, or undefined. Okay, so hopefully this is mostly a review based on what you learned about linear equations. So the idea of a linear function is simply that the function is the right-hand side of a linear equation, where you have y on the left, and what's on the right is this function. Okay, so we did something like this before. If you have it in standard form, if you have an equation in standard form, then, for example, if b is not equal to 0, capital B is not equal to 0 here, then you can solve for y. And get y as a function of x. Okay, so you're changing the linear equation, which is not of the right form, into a form in which you can immediately identify the linear function involved. So a linear equation will always give you a linear function by solving for y, if you can solve for y. If you can't solve for y, b is equal to 0, and then you get this equation here. If assuming a is not 0, you can solve for x, and x will be a constant. And that's not a function. Okay, so only in the case of b not equal to 0 can you solve for y and get a function. Get a function. And what is it? Explicitly in this case, it's y is equal to, we put the other terms on the other side and divide by b in both cases. So this is my function f of x. And it's the same as this form as long as you take a is equal to minus a over b, and b is equal to the capital C over b. These are capital letters, these are small letters. They're different here. Okay. All right. So now I would like to continue up ahead with quadratic functions. So this is now starting chapter 5. Okay. And these are functions of the form y is equal to, well, we don't have to write that in, but f of x is equal to ax squared plus bx plus c. So these are important, and I want to review some of the properties here. So we've already done some things to describe these functions in general. So this is one step up from linear functions in that instead of having just the linear and the constant term, the linear term in x and the constant term in x, Okay. We also have the quadratic term, ax squared. The general a is not equal to 0 here. Otherwise, we just go back to a linear function. With it's going to have a simpler behavior. Remember, the slope is always the same. It doesn't depend on which two choices you use for points in the graph to determine the slope. And it's either always increasing or always decreasing or always constant. And you can never have a vertical line. Now if you choose a not equal to 0, remember our possibilities. Okay, here we have 3 parameters to determine the whole graph, a, b, and c. So in general, those 3 parameters represent 3 degrees of freedom, and you can express the 3 different parameters in quite a number of different ways. One way was, as I showed before, you can complete the square. By completing the square, you would then, as I showed before, you would get an equation of this form, or a function of this form. A times x minus h squared plus k. So there again you have 3 parameters. A is the same as before. H is a new parameter, which is the x-coordinate of the vertex, and k is also a new parameter, which is the y-coordinate of the vertex. H and k are expressible in terms of a, b, and c. So these are 3, altogether there are 2 of them are new, I guess, but we call them three different parameters, or a different choice of parameters. 3 of them. They're basically 3 independent parameters. You can vary each one independently of the others. Okay, so generally have a parabola like this. Here's a point hk. So geometrically, this is a nice way to write it because the h and k immediately tell you where the vertex of the function is. That will be a minimum point if a is positive, and a maximum point if a is negative. Okay. And if a is 0, then we have a linear function again, and h and k will not be a vertex there at all. Actually, it will be just a constant function in that case. Well, you can't even complete the square in the linear case. If b is not 0, then there's no such operation. Cat doesn't work. Okay, so now the geometrical significance also of h, k, and a are that they are shifts of the graph f of x is equal to x squared. So remember, they are transformations of this toolkit function. So changing the sign of a will flip the graph over the x-axis. Right? So if a is negative, then you get a reflection about the x-axis. So you get a shape like this. And if a is if the magnitude of a is different from 1, then you get a stretching in the y direction if a is bigger than 1, or a shrinking in the y direction if a is less than 1 in absolute value. And the h and k are just a shifting of the vertex from the origin to the point x, h and k, h, k like that. If h is positive, then I shift to the right along in the positive x direction. If h is negative, I shift to the left. I shift the vertex to the left. And if k is positive, I shift vertically upward. If k is negative, I shift vertically downward by k units. Sorry, that's the value of k units. So now I would like to put this together, these two types of functions that we've just been reviewing, and discuss cost, revenue, profit. And I'd like to base this on the problem that I gave on quiz 1. So this is now quiz 1, chapter, number 2. Okay, so what we're given here is the price in dollars corresponding to the demand of x units per day of a product is equal to P is equal to 6 minus x over 200. Price in dollars corresponding to the demand of x units or a demand, I should say, per day of a product is equal to, P is equal to 6 minus x over 200. A, question first part is find the price P and demand x at which revenue per day is maximized. Okay, so now what will happen here is that this is a linear function. P, the price, is shown here as a linear function of the demand of a certain product. So the demand of a certain product is basically how much of that product can you sell per day? How many items are people willing to buy per day? Okay, so generally in economics, if the price goes down, or in other words, then the demand will go up. And you can see that here as this thing has a negative slope. So if the product, or if the demand is greater, if X is greater, that's how much people will buy per day, then the price will be correspondingly lower. There we're thinking of price as a function of demand, but you could also solve for x in terms of P, right? And then that would give you, that's finding the inverse function actually, and that will give you x as a function of P, or demand as a function of price. So sometimes people will look at the price and that will determine whether they buy it or not. And the greater the price, the less likely they are to buy it. If the lower the price, then they might decide to buy it. Okay. So the price function is given by this simple linear function. It can be complicated in general, but we're thinking of a model in which price has a simple, easy dependence upon x in this case. Okay. Now the revenue is simply how much money is made per day by the purchase of all the x units. Right? So people will come in, they will buy x units per day, given that price. And the revenue is equal to the demand times the price. Okay. And in this case, that will be x times the price, 6 minus x over 200. So we're expressing the revenue now as a function of x. So P was expressed as a function of x. We can write it like this. But the brackets does not mean multiplication, it just means functional dependence. What is the input and what is the name of the function? Okay, so this is the revenue function. And now we're asked to find the price and demand, x, at which to find the value of P and find x such that this function is maximized. Okay, so you can see what the values are here, which will give you kind of unrealistic values for revenue. So the revenue, you assume, should always be positive. So if this is a feasible business, you should not be paying people to purchase your items or your wares. You should be getting some revenue for what you're giving to them. Okay, so the revenue, there should be a range, or a domain now of x for which the revenue is positive. When is it positive? Well, it's when both factors are positive or both are negative. But x cannot be negative. So that's out. Or x is positive and this other factor is positive. Okay. So this will work. So x has to be a positive number. You actually sell items. You don't take them in somehow. You're not buying them here from your customers. And x should be, this will solve and give you x is less than or equal to, x over 200 is less than or equal to 6, or x is less than or equal to 1200. So there's a maximum value of the demand above which, what happens to this factor? It becomes negative. So you don't want to sell things at a negative price either. That's wrong. So this is the demand. This is the range of the revenue function. Sorry, the domain of the revenue function. Okay. So the revenue, the range of the revenue function given this domain will be, well, anything bigger than 0, that it's going to have to be bigger than 0, that's for sure, according to this equation. But it'll also have to be less than the maximum value. So that's the range. But we're not really asked for that. We're just asked for what is the price in demand at which the revenue is maximized. Okay, so to do this, we need to, first of all, recognize that this is a quadratic function, and then find the picture of the quadratic function. In other words, we can graph it, or we can find the vertex. And that we obtain by completing the square. Find the vertex by completing the square. So the vertex is what we want. for this parabola, because that will tell us what the actual maximum value is and which is the x value that will give us that maximum, and also from x we can determine the price. The price function is given by this. Yeah. Find the vertex by completing the square. Okay, so here we have our function. To complete the square, we expand it out. So eliminate the brackets, expand this out. So I get 6x minus x squared over 200. And you can rewrite it if you like, like this. And then we identify the coefficients a according to ax squared plus bx plus c, right? The usual way of writing a quadratic coefficients of a quadratic function. A then is minus 1 over 200. Like that. And b is 6. C is 0. There's no constant term here. Right, now how to find the vertex? Okay, one way is you can complete the square, which is what I was suggesting to do there. A little faster way actually is to use this formula. H is equal to, remember that formula? Minus b over 2a. Okay, so you could remember that formula, and that's obtained just by starting with the process of completing the square. Then you'll see that you'll have x minus or x plus b over 2a inside the brackets there in the square. Right, we'll get that by working on completing the square by putting this in brackets, and then you take the a out, and this becomes b over a x plus, and then you have to divide that by 2 and square it, so it's b squared over 4a squared plus c, and then I'll get minus b squared over 4a, because the a squared cancels with an a there, and gets just 1a in the denominator. Gives you just 1a in the denominator. So we don't really, this part, you might want to remember that, but the easy thing to remember is x plus, this is b over 2a squared. So that tells us h is equal to minus b over 2a. That's the x-coordinate of the vertex, and that's going to be minus 6 over minus 1 over 200. And there's a factor of 2 here. Okay, the minus signs will cancel, and I'll get 6 over 2 is 3 times 200 is 600. That's h. Now to get the constant k, this will be k. That was minus h. To get k, we can either use this formula, or, even simpler, just substitute into the original function the value of h that we got. That will give us k. So remember how that worked? That's because if we substitute an h into this, x minus h squared, that gives us 0 for this. So we'll automatically get, as a result, we'll get this formula. Okay, so 6 times h, which is 200, minus 200 squared over 200. What does that give us? 1200 minus 200. I'm sorry, 600 should be in there. H is 600, so it's 6 times 600, and then minus 600 squared over 200, so that's 3600. This is 36,000, no, 360,000 over 200. So the zeros will cancel here, zeros will cancel here. This will be 3,600 minus 1,800. So it should just be 1,800. Okay, that would be the revenue of 600 items, obtained by selling 600 items. Let's just check that with the price as well. Price is what? Originally it is 6 minus x over 200. So the price is 6 minus, oh, something wrong here. Oh no, it's okay. 600 over 200. So that's divided by, that's cancelled and I get 3. 3 over 1. So 6 minus 3 is 3. So it's $3 per item. What's the total x again? It's 200. Yeah, so something went wrong here with my calculation. Let's see what I did wrong. Oh no, it's okay. Yeah, so the revenue function is x times p. The value of x that I found was 600. The price is 3, so that does give me 1,800. Okay, so the total revenue is, like the maximum revenue is $1,800. Actually, we weren't asked, in the original question didn't ask for the actual maximum revenue. I found it anyway. So we're just asked for the price, which will give you that maximum revenue, and the demand. Give me maximum revenue. Okay. Now the second part involves a linear function here. Another linear function besides the price. The price was already a linear function. And that was, we're given the cost of production per day of a number x items. So the cost of producing those products that are being demanded every day, that people are buying every day, is called C of x. C of x is what here? It's equal to, given as 4x plus 50. Again, this is in dollars. This revenue is in dollars. So what this means is that we have this constant value here, and we have a varying factor here, or a linear factor. Obviously it's increasing, because the more items you produce, more items x that are being produced in order to meet the demand, the greater the cost of producing those items. And if you don't produce any items at all, x equals 0, then there's still this so-called fixed cost. So the cost function breaks up into a fixed cost, which is a constant value, constant term, and the variable cost, which is the number of items produced this coefficient is a cost of producing simply one item per day, or one extra item per day, not including the fixed cost. So the cost function we're given, and it says find the profit and demand. In other words, we now have another function yet again. It's p of x, which is a profit function. Profit function. So it's the amount of money that the company makes by selling these items. So it's a profit per day. This is a cost per day here. The revenue is also a price per day. So the revenue function, it's the revenue function at that demand per day minus the cost function. So the amount that you gain from selling the product from X items per day, right? So it's the amount of money that you make by selling X items per day minus the cost of producing those X items per day. Okay, so writing it all out, what we'll get is X times, and as before, it's 6 minus X over 200. Revenue function is before, and then minus 4x plus 50 in brackets. Okay, so this is now a different function than before. And it will also turn out to be a quadratic function. And we can also find the maximum of that. By the way, why is it a maximum? It's because the coefficient of x squared is negative. I forgot to mention that before. But here we'll write that out, and it's going to be minus x squared. So the coefficient of x squared is the same as before for the revenue function here, but the linear part will change. 6x minus 4x, and then we'll have a constant minus 50, because the negative sign goes on both terms. So this is minus x squared over 200 plus 2x minus 50, like that. Okay. I guess we're getting to the end here. So now, did I do it right? Yeah. Now we have to maximize this quadratic function, or find the value of x which maximizes that. Okay. By the way, what did the revenue function look like? We should just graph it to help understand what it looks like. Here's the range, or the domain that we found for r of x. Okay. Looks something like this. Symmetric with respect to the central value, which gives us the maximum. So we found that to be 600, halfway between 0 and 1200. And our maximum was 1800, as we found, $1,800. Okay, so that's what the revenue function looked like. Now we're going to have to graph cost function, or at least find the maximum, the point x, which gives you a maximum value for that function, and find the actual maximum profit. So we have to find the demand at which profit is maximized, and find that maximum profit. again, the simple way of doing it is you could identify the a and the b in the quadratic function. Ignore the c for the moment. Here the a is minus 1 over 200, as before. B is, excuse me, b is now 2 instead of 6 as it was before. And so you find the h as minus b over 2a, which is minus 2 over 2 minus 1 over 100. And that's going to give me, cancels 100. Okay. It's b, not 6. Okay, so it's now closer to the origin where I have the maximum. Oh, sorry, I did something wrong. That should be 200. Oh, so it should be 200. Okay, it's closer, not that close, not that much. It's right over here somewhere. So here's where I have the maximum now of the cost function. It will have the y value k of the profit function will be, the profit itself at the maximum will be, I just substitute in x equals 100, sorry, 200. So I get minus 200 squared over 200 plus 6 times 200. Sorry, looking at the equation, 2 times 200 minus 50. This is minus 200 cancels with 200 squared, and I get just minus 200 plus 400 minus 50, so that's going to be 200 minus 50 is 150. So the profit's going to be, well, much less than the actual total revenue. I guess the cost is going to be quite large at that revenue. So it's going to be 150 here, profit made per day. So it's going to look something like that. And I'm going to have a negative value unless I produce some items. So if y is 0, then I'll get values here. So the shape of the graph is the same as above, but it's shifted over here, something like that. And there's something called the break-even points, which I could also ask about. So the break-even points are how much you have to produce and sell in order to break even, in order to get zero profit. Okay, so since it's already getting a bit late here, it's about 25 after 7 at one time, or it's over now, an hour and a quarter for your time for the total lecture. I'll quit here. I'll just write that down. It's a useful term. So you might want to check out what are the break-even points, i.e. x for which cx is equal to 0. Okay, so there you have to solve the quadratic equation. You find the roots of cx equals 0. Okay, so next time I will, again, I'm sorry I have not yet gotten your homework back to you and graded and evaluated and gotten feedback. I'm going to work on that as much as I can in the next few days. Just to let you know, I was working also on an assignment that it was a volunteer project to evaluate a paper written by somebody, and so I was working on that, and That's been taking more time than I thought. It's for a journal, academic journal. So sorry for not giving some feedback yet, but I plan to do that in the next few days. Get your homework back. Right. So next time I'd like to talk about the higher order polynomial equations or polynomial functions. So this is more in chapter 5. So chapter 4, I did it briefly because I think it's mostly a review of things you've done before in previous math courses. And we've already done quite a bit of quadratic functions, covered at least the first section of chapter 5. So this will be basically section 5.2 and beyond, which I hope to start with next time in the next lecture. So the next lecture will be today's the 14th, and so the next lecture will be on the 17th of November. Same time, 6:30 p.m. your time. Okay, so please, if I haven't told you already, please try to read ahead in the textbook. You could also review other textbooks for the subject material. Oh, and I would like you to do the homework for next time as practice. Do the practice test at the end of the chapter. There's a practice test at the end of the chapter. I'll tell you where it is. It's the end of chapter 3 here. Yeah, it's on page 277. Okay, and now to make this simpler for me to grade, just send in. Okay, do all the work. Show all your work on your own pages, but you don't have to photocopy them and send them in. Just email me the answers. So try not to look up the answers in the book, but just try to email me your answers. So it'll be like what is done on the Maple TA test. It makes it a bit easier to grade. If you have trouble with it, then you can always show me your homework by taking a picture. Send it in, and I can try to identify what your mistakes might be, if you make any, or whether there's some misunderstanding or whatever. So that's better to be done in real time, and then you get feedback. Once I see it, I can immediately respond and help you there, and that's a little bit easier than you submitting all the homework and then it takes me a while because of all these other things to do. I don't get the homework back right away, so you're delayed in getting your feedback. So just email me your answers. In any case, you can practice. Use it for practice. I won't count it. Just to see that you're doing it, just emailing me your answers. So if I see you're having a problem with it, I could identify that. I probably won't count it as homework, but I want you to do it for practice. I'll give you other assignments by Maple, which will be graded. That will be similar to this. Okay, so that's all for today. Have a good day, Chudofes, and Shabbat Chush. Have a good night.